So welcome to Dynamic Foundry Group. Today we have a very interesting technical talk with Mr. Prakash Mugali of Enerzi Industrial Microwave Drying Oven Technology from Belgaum. And we all know the core section is very important section in the foundry. And after making the core painting and core drying is a very important factor. And most of the foundries, most of the people are not focusing on this area, which causing them various defects, various problems in the casting after machining. So I think this is a right way to discuss on this topic, how to paint the core, how to dry the core, what are the new additional technologies are coming up in that area. And for that, we have today with us Mr. Prakash Mugali of Energy Industrial Microwave Drying Oven Technology of Belgaum. And I welcome him and hand out the platform to him to continue his presentation.
Thank you. Thank you very much, Mr. Sandeep. So I'm Dr. Prakash Mugali, founder and CEO of Enerzi Microwave Systems Pvt Limited. And we work in the industrial microwave heating space. And we are here to discuss about our new product for the foundry sector. And we are calling this system as an Enerzi Industrial Microwave Drying Oven. In short, EMDO is the product name, right? And just to take you through, we are a company working with interdisciplinary expertise in our organization and with a vision of being a global brand in material processing solutions. And our mission is to provide innovative, economical, energy efficient, and eco-friendly engineering equipment and solutions for food and different materials processing. And our team consists of engineers, experts in the area of microwave engineering, automation, power electronics, thermal engineering, instrumentation, and material science. We have been serving more than 100 global clients over the last decade. We have a combined technological experience of 200 plus years in our team. And we have won 7 prestigious awards in the country, filed 9 patents, and we have 4 R&D collaborations for product development. These are some of our prestigious customers, and we work with varied industry segments in ceramics, in rubber, in different polymers, and also special metal powder synthesis applications. We have various research partnerships. We work very closely with academic institutions and also research organizations like National Aerospace Laboratory. And we have a couple of foreign collaborations on various technological aspects. We recently also signed up with a company called Muge, Germany for a diamond synthesis application with microwaves. These are some of the awards that we have received for our innovative product development that we have launched, and also the kind of energy efficiency that we have established in various applications across various segments. So coming back to the products, we have a couple of standard products, and one of them being the continuous rubber vulcanization line, which is basically a microwave and a hybrid heating system used for rubber profile vulcanization, for vulcanizing automotive profiles, for industrial tubes, industrial gaskets, and things like that. And we have a laboratory scale sintering furnace which we supply to research organizations and educational institutes. We are also into industrial custom-built solutions, building microwave machines for a variety of applications, ranging from resin mill curing to vitrification to food and fruits and vegetable drying, and some very niche applications like microwave plasma synthesis and coal processing systems. So, having given you the background about our company, let's talk about what this technology can do for Foundry and why is it so important for foundries to look into this technology and bring this technology to intervene in the industrial drying of cores and molds in the industry, in the foundry sector. So for all from the foundry background, this is not a new chart. I'm sure you all know it very well. We're talking about the core and mold making process. If you look at any foundry, irrespective of what kind of technology we are working on, either a green sand or machine molding or high speed lines or any of these, the core and mold making process involves a step of coating the surface. Now, primarily, there are two different technologies in coating that you all know. One is using a water-based paint, and another one is using an alcohol-based paint as a coating media. And for few advantages, we do it in Foundry. And these coatings, once done, have to be sort of all the either the alcohol fluid or the water needs to be taken out of the core. Otherwise, it will have a negative impact on the casting quality. That's also not a secret. Everyone knows it. So what traditionally industries that or foundries we have known for using is using an alcohol-based paint and ignite that the core or mold which is coated with alcohol-based paint, eventually to take out the alcohol portion from it. But then it's observed that the quality is not as superior as using a water-based paint, and also there are connected health hazards. In case of using an alcohol-based paint and then igniting it eventually in an open atmosphere is not an acceptable, safe method in an industrial environment. So what do? We go for a water-based paint, and then the water-based paint is eventually applied on the course, surface of the course, either manually using a brush in some cases or using a spray gun. And eventually, and even some places we use dipping methodology or pouring of the liquid paint on the course. So depending on what kind of finish you require, what kind of consistency you require, and what kind of quality you require, different industries use different methods to apply the paint. And after the paint is applied, we need to dry these cores, and we need to take out the moisture which is penetrating into the core, which is predominantly surface phenomena. Most of it, the water in the paint is in a few millimeters of the core on the surface and not really penetrated into the core. So what do we need to do to remove this moisture? We need to dry these cores. And some of the current methods of drying, how are they dried? These cores are dried. Either we use a gas or diesel fired dryer, or we use an electrical dryer, or sometimes we're using infrared dryer. And if it's, as I told, if it's an alcohol-based painting, then we go for igniting or applying flame with a flame gun. So if it's infrared or electrical, in both the cases, we are converting electricity into heat using heaters. In the case of infrared dryer, it's just the infrared radiation that's falling on the product, which is eventually drying. In case of an electrical dryer, necessarily it is an electrical heater with air being circulated, and the air is heated and we try to take out the moisture. In case of gas or diesel fired dryer, again, there is an airflow, but the fuel source is essentially gas or diesel. Now, there are some problems or there are some limitations of using these methods. Primarily, one of them being an uneven drying phenomena. We don't get a consistent uniform drying across all the regions of the oven. It's a challenge to achieve that. Most of the cases, there is a pollution that these methods are contributing because of the cost aspects. Very few people use, or very few industries go for electrical based dryers. They are using either a gas fired or a diesel fired system, which is having a concern of pollution. You have often challenges of fuel shortage and spikes of fuel prices, and then having a challenge of controlling cost of drying. Power efficiency is quite poor in these dryers. The unit power consumption to the result that you get, that ratio is quite poor. And these processes are time consuming because you rely on conduction and also convection of these the heating methods to pull out the moisture from the product. It's quite easy to take out the moisture from the surface, but to pull out the moisture from inside takes time, and it's a slow process. And some of the methods, as we discussed, are also hazardous. So is there an alternative to all these issues? Is there an alternative method that we can think of? Yes, there is, and that is where this microwave technology is playing a great role. Just before we go to what this microwave dryer is, let's see what is this microwave heating concept itself. So essentially, microwaves are electromagnetic waves, and it's a spectrum of different wavelengths. And the electromagnetic spectrum between 0.3 gigahertz to 300 gigahertz is what is referred as microwaves. And in that spectrum, there are only few frequencies which are allocated or allowed to be used for heating application, and those three are 915 megahertz, 2.45 gigahertz or 2450 megahertz, and 5800 megahertz. So these three frequencies, which essentially are L band, S band, and C band frequencies, are only reserved for heating applications, and rest of the frequencies in this 0.3 gigahertz to 300 gigahertz are kept only for communication applications. Now, what happens when these electromagnetic waves of any of these frequencies, when they fall on any material, there is a molecular vibration that is created because of the electromagnetic energy. And this these molecular vibrations, they give rise to heat energy. So the heat is generated in the material, and that heat energy and it also depends on the electrical intensity of radiation that's going on the material, and that's how the heat energy is computed. So the heat energy is sort of equal to 2 pi f epsilon naught epsilon double dash ei square. So higher the power, higher will be the heat. Higher the frequency, higher is the heat. And also more the we call it as dielectric loss, epsilon naught epsilon double dash, more of it, more will be the heat. And what happens when these electromagnetic waves fall on the core or any substance, whether it's a ceramic, it's a rubber, it's a food product, or it's a wooden log or sand core, when the microwaves are incident on this block of material, portion of it gets reflected back, and a portion of it passes through the material without getting absorbed in the material, and the portion of this incident waves is absorbed in the material, and it gets converted into heat. Now, depending on what is the property of the material, and also depending on which category this material falls into, whether it's a metallic product, whether it's a ceramic or a polymer material, or whether it is a transparent material like glass or quartz or Teflon, the portion of reflection, absorption, and transmission, they change. If it's a metallic body, a solid bulk metal, then 99.9% I would say, or majority of the incident waves are reflected back. Hardly any energy will pass through it, and hardly any energy will be absorbed in the product. If it's a glass or Teflon on which you make microwaves fall, then majority of it is transmitted, portion T, right? Where it's neither absorbed nor reflected. And then if you use a material like sand core or silicon carbide or ceramic, or you have a wooden log or things like that, which have got absorbing characteristics, then majority of this energy gets absorbed into the block itself, into the product or the substance itself. And that's how we categorize these materials as microwave transmitters, microwave absorbers, and microwave reflectors. What we are interested in using this technology, or this technology is useful in applications where the materials are microwave absorbers. That's why microwaves cannot be used for melting metal. It's not meant for melting the metal because it gets reflected. And neither microwaves are used for heating quartz or heating Teflon or other materials which are transparent. This can only be efficiently used for water-based products where drying is involved, or heating high temperature applications where ceramics are absorbers of microwave, like silicon carbide or other ceramics, or heating polymers which are carbon-based, which can absorb microwave energy. So microwave heating has got very niche applications. So just to reiterate, what is the principle of microwave drying? If you look at a core body as a combination of sand particles and water particles, right? So let's say you're looking at this left side image where green dots represent water particles and the blue dots represent sand core. My sand core is silica, SiO2, and silica is transparent for microwaves. So silica does not heat. If you have a completely dry silica block, pure silica, which is quartz, it simply does not heat with microwave. But the water particle H2O in that is highly absorptive. So if you look at the zoomed version of this image on the right side, the water particle absorbs most of the microwave energy that you are giving, and it creates a molecular vibration. It heats up, its temperature rises, it changes its phase. So from solid it becomes a vapor. So microwave is selectively heating the water particles both on the surface and inside the core efficiently. And that's how the core gets dried very fast, because we are not creating heat from outside and supplying to the core. We are actually just supplying electromagnetic energy, and the heat is generated in the core. It's not heat supply, it is heat generation, so it is very fast and efficient. So what are the key advantages of microwave heating? Number one is selective heating. It's, as you just saw, it doesn't heat the silica particle, it tries to heat the water molecule. Now, of course, when you heat water particle, it is going to conduct the heat to sand particle to a great extent, because it's surrounded by sand particles. But nevertheless, the heating is more directed, more selective. So the efficiency gets enhanced because of that. Then it's very rapid and direct heating. We are not trying to heat the surrounding. We are not heating the air. Of course, when we build and design and build hybrid ovens with heated air circulation and microwave, there is air heating, but that's to carry the moisture out. Essentially, microwave is doing the job of vaporizing or getting the water particles out of the core, and the heated air circulation is meant to carry that moisture out. So we say it's very rapid, and it's a direct way of heating the product. And there is a phenomenon called bulk heating, meaning we are not heating only the surface. Like if you take oil fired, gas fired, diesel fired, any of these methods, electrical heating, infrared heating, in all the cases, the heat is generated outside and the heat is given to the core. So the surface will heat first. And because of conduction of heat, the heat will go inside. So the inner water will get the heat quite late, and you have to be very, very slow. And also, in spite of that, you will only see dry surface on, or dry, dryness or dry core only on the surface, but there may be moisture left in the core. That's why another way of testing is you take out the sand in the core and then you test, right? So to check how much moisture has gone out. Whereas in microwave, it's bulk heating. The microwaves will pass through the core on the surface and through the core. It will enter simultaneously, and you're able to take out the moisture from the surface as well as from the core together simultaneously as you start heating. That's why we call it as a volumetric heating technology. It's a bulk heating technology, not a surface heating technology. And besides, it's a clean technology, very little carbon emission, that too only because of the source electricity that you generate. Otherwise, there's no toxic gases, there are no fumes coming out, and it's a green technology. We are also working with governments to see if carbon credits can be attached to this technology, and then you can claim the benefits of being a clean factory because of introducing this technology in the drying process. So what does all these benefits mean? What are the advantages translate to in case of the end economics for the foundries? Number one is the operating cost is very low compared to what we have seen in the benchmarking oven that we built. There is a cost reduction of 300 to 400 rupees per ton of drying compared to conventional drying methods. There is at least 50% reduction in the drying time compared to anything that you do with any method. And then at least there is a 15% reduction in sand core inventory. This is based on how you can implement the just-in-time and how can you use these core inventory limitations. Then we've seen lower rejections because the consistency of drying is a lot more. We are going with a continuous system with uniform drying, so the rejections are quite lower, both in the core itself and the castings that are produced with these cores. And the contribution to environment is, I've already explained, it's a sustainable technology, it's a green technology. We are talking about 25 to 30% reduction in the energy consumption for the same unit of drying. On your shop floor, the material flows are much better due to continuous operation of the oven, and you can establish a material flow where no piling happens of the cores. In most of the batch processes, it does happen. Right? So these are some of the qualitative advantages of this technology. And this is the first microwave dryer that we built as a pilot machine for demonstrating the advantages of the cores. And we have this dryer located in Belgaum in our factory. And any foundry is welcome to visit and see this dryer and carry out some trials in this dryer to prove to themselves that there is advantage of microwave drying. And this is a small oven of about 3 meter length, and can dry up to about 200 kilograms to 250 kg of cores per hour. And based on this demonstration, we recently installed a high capacity dryer of 1 ton per hour in Foundry in Belgaum. I'll share also some photographs of the same. So what we have done is we've proposed three size ovens, three size dryers. MDO 200 is a 200 kg per hour capacity dryer, MDO 500 is a 500 kg per hour, and MDO 1000 is 1 ton per hour. We could definitely design larger scale machines if required, but what we've seen is most of the foundries requirement is covered in these three sizes. And the installed power we have given for 13.5 kilowatt for the first one, 32 kilowatt for a 500 kg per hour machine, and 75 kilowatt for MDO 1000 kg per hour. And compared to conventional electrical dryers of the same capacity, the installed power and the consumed power is at least 25 to 30% lesser in these ovens. The operating temperatures are 140 degrees Celsius. And of course, you can see the footprint and the core capacity. The core sizes that I mentioned here, it's an indicative size. We could alter the size of the cross section or entry point depending on what your range of cores are. That can be done. And just to take you through, so this is the production machine with a capacity of 1 ton per hour. And these photographs are the photographs when the machine was under installation. It's been now in operation for about 8 months, and excellent benefits are reaped by our customer. And it's a pusher design with almost 90% automation, with the operator only handling the buttons to move around the trolleys. These trolleys are wheel, they have a wheel, and then they are connected to a chain system with a transfer trolley. And it's a complete loop. The trolleys will enter in the dryer, and then they will come out, and then they will take a U-turn, and the trolleys will come back. And on the way back, there is unloading of the dried cores and loading of the fresh cores on these trolleys. So that's what you see. So on the left side is what you see is the return trolley channel, and on the right side is what you see inside the tunnel. These trolleys are entering inside, they are inside, and these cores are loaded on the shelf. These trolleys are adaptable. If you have a large core, then you can just keep the core on the floor. If it's a small core, then you can also have 3 shelves. We have portable removable trays, and the trays will go into these trolleys. So you can create 3 shelves on this trolley system. So that's a more overview of the entire system. You have the control panel on the right here, where you can control each magnetron. This system currently has about 8 microwave sources, 4 on the left, 4 on the right, and it has got capacity to increase up to 1.5 ton. We have provided additional sockets for additional microwave sources. And this is where the operator stands, and there's no manual intervention inside whatsoever. And this, what you see with the hood, is the transfer trolley. and the transfer trolley can move on the left and right to receive the returning trolleys or to load the fresh trolleys into the dryer. Yeah, so this is on the other end of the oven where the trolleys are coming out. And this also has a heated air circulation. So if you can see this, the hood, and from there is a ducting that you can see, and this ducting carries the heated air. So microwaves are heating these cores from the left side and the right side, and the moisture is taken out, and the heated air that is entering into this, it is going to carry the moisture out of the dryer, and then it is connected to an exhaust here. The proportion of exhaust to recirculation of the air can be adjusted in the adjustable baffle plate here, so that you can control the fresh air entry into the system or the air changes of the dryer. Great. So this is what we have done, and we are now talking to a few other foundries to build these dryers for them. So we definitely welcome all the foundries to carry out some feasibility trials at our end. At the same time, we also welcome the existing oven manufacturers across the country, because we have decided to license this technology and work with the existing dryer manufacturers. We do not want to be a single company making microwave dryers and become a competitor to existing oven manufacturers and get into kind of a competition or a battle to prove which technology is better. We believe, or I believe strongly, that this technology has a lot to offer for foundries, and I have a strong feeling that in our country a lot of foundries use this technology. So what we are doing is we are open to talk to existing oven manufacturers. In fact, we are already in the talks with two of the biggest oven manufacturers in our country, and we want to be a technology provider, provide all the know-how that we have about the design of these dryers, provide the know-how of how do we design and build these ovens, also provide them the technical support of how do they convert their existing electrical dryer or diesel dryer to a hybrid microwave dryer. The beauty of microwave technology is you can combine this microwave technology with any of your existing technologies. If you have a design of a diesel fired oven, you can bring microwave into the existing diesel fired oven. So it will be a diesel plus microwave, and the diesel can work as a source for heated air. Microwave can work as a source for driving away the moisture. You will still get the efficiency benefits. If you have an electrical dryer, you can combine it with electrical heaters and microwave. So any technology that you as an oven manufacturer are doing can use this technology, work with us. We can become your partner to supply all the microwave components where we have expertise, and we have created a lot of IP and expertise and products in this area. We can supply those components which are made in India, and help you become a microwave oven supplier to foundries along with us. So we are very excited about this new strategic decision that we took, and we believe in the coming months we would be able to translate many of these deals and then start implementing microwave technology widely into Indian foundries. So thank you very much. This is our website, enerzi.co, and email ID and phone number for anybody who wants to reach us out. We would be eager to work with you both with foundries and also with oven manufacturers. Whichever way we want to work, we are open to take this technology forward into this country. Thank you very much. Thank you, Sandeep ji. So that is all I have. If you have any questions, we can discuss that.
Yes, thank you. Thank you, Prakash ji. It was a nice presentation. I have a few questions actually. Some of them have been answered in your presentation as well, but I want to elaborate it little more, so I'm asking the same one once
Sure.
again. First question is why these core ovens are required, basically.
So yeah, as I explained, core ovens are very essential part of any foundry today, because you are essentially improving the surface quality of the molds or cores. Molds surface quality, of course, the mold cannot be moved except in shell molding. In rest of the technologies like CO2 or rain sand, you cannot move the mold, so you have to apply the paint on the spot itself. But the cores are mobile, and either you use a CO2 core or shell core or any of these. To improve the surface quality, you are essentially painting them, and once you paint it, you need to dry them. So basically, earlier we used to also have core baking ovens. So we are not talking about baking the ovens with this technology. It's a drying oven where the prepared core, already made core, after applying the paint, you need to dry the moisture out. One of the applications which very interestingly is also emerging is a couple of foundries have done very successful trials on core assemblies using core paste, and the core paste drying in the microwave oven. That is proven to be very efficient and very fast. They are able to get the core paste curing done very quickly and get the core assemblies ready without expending a lot of energy. So core ovens basically are required to dry the cores.
You mean shell core assembly?
Shell core assembly, that is for the core paste drying.
Core paste drying.
For paint drying is shell core or shell mold or CO2 core. Any of this, it can be used.
Yeah. You talk about the mold, that is a shell mold. It's
Yeah.
Yeah. One more thing, you are talking about drying or baking. It's only a surface or inside also?
So it is drying only. It is not baking. We are talking about drying, but it is drying for surface as well as core. If you have a CO2 core, then you have moisture even inside the core. That can also be dried in this machine.
So how you can ensure that the core is totally dried from outside as well as inside? Is there any test available for that?
Yes, of course. So the technology of microwave, it is penetrating into the product, so it will dry together. But to verify that, what we have done and what anybody can do is you can dry the core and then you can break the core, and you can take the sand sample from surface as well as inside the core and test it in the standard moisture test equipment in the lab.
Sand sample means you can cut the core and take.
Yeah, we can cut the core and you can take the sand sample from the core.
From the surface as well as from the center of the core.
Yes,
portion.
That's
and
right.
It should be quite equal or
yes,
similar,
that's
almost similar.
Yeah.
Okay, great. What should be the minimum temperature required, and what should be the timing for this drying you recommend?
Yeah, so here the temperatures are around 140 for the heated air. Anywhere from about 120 to 150, you can vary the temperature. You can set the temperature, it is in your hand. We recommend the heated air temperature to be kept at 120 to 140. And the microwave is power controlled. You can set the power, and the temperature will be limited in that range, 120 to 140.
And regarding the curing time?
So curing time, depending on the size of the core, it can vary from 10 minutes to about 45 minutes.
So it can be adjusted by controlling the speed of the conveyor.
Yeah, that's right.
By adjusting the speed of the conveyor.
Speed of the conveyor, speed of the pusher.
You can control the timing.
That's right.
During your presentation, you talk about the absorbing. Then one more is transferring and what
reflectors.
Reflectors. Okay. Yeah. So you said that the cores, particularly silica sand cores, are the absorbers. Correct. So it is because of the permeability that we have in the core.
Because of the permeability of the sand core and the water moisture available, they become absorbers.
Okay.
Yeah.
And glass is the total transfer.
Yeah, not all glasses. If it is borosilicate glass, it also absorbs. But if it is pure silica glass, silica quartz glass, then it is transparent.
Transparent.
Yeah.
So as you say in your presentation, the principle of this particular drying is you are supplying these microwaves which go inside the core of the we can say center of the core. It absorbed by the moisture. Then it gets evaporated,
vapor.
And vaporization is there, and it creates the heat, which automatically that
once it becomes the vapor. Yeah, once it becomes the vapor, because of vapor pressure, it will come out of the core.
Yeah.
And because of the hot air, it will be carried out of the oven.
So your moisture goes down, means your core is already dry.
Yes.
So that is why it is been dried inside also. That is what you
Yes.
you are like to say.
That's right.
And what is the approximately cost per
So
kg
we have
for this?
yeah. So as I spoke to you, we have these three sizes that we have sort of launched as a reference sizes. Of course, each customer to customer the sizes change, but the price goes depending on the cross section opening and also depending on what features we want. Whether somebody wants PLC control, a touchscreen control, somebody wants basic. But you could say roughly it would lie anywhere from about 13 to 14 lakhs for the smallest machine to about 30 lakhs to the largest machine, the basic machine.
And the operating cost?
Yeah, so the operating cost is between, you can say 320 to 360 rupees per ton of core.
Okay. So approximately 35 paisa to 40 paisa per kg.
Per kg.
Can we use no-bake core and other, that is CO2 core through this oven?
Any core.
Any core. So there is no restriction like that.
No restriction of anything. You can use any.
We have to go for water-based paint for using this dryer.
Yeah. It is only for water-based paint.
We can't use it for the alcohol-based.
No. It's a little risky for alcohol-based because there could be ignition inside.
Ignition will take place.
Yeah.
Okay. And is any particular recommendation for keeping the viscosity of the paint, or what should be the paint thickness for better result?
Yeah. So there is a range of viscosity that people can use, but that is there is no issue whether you use lesser Bombay or high Bombay. It depends solely on what kind of finish the customer wants and how much coating thickness they want to build. It doesn't impact the function of the oven. Only thing is, if you use very thin paint, then the water absorption by the core will be very high. A lot of water will be absorbed, so your drying time will increase, and you have to also keep higher power for drying, so your drying cost will go up. If it is a thick paint, quite thick, then the moisture absorption is limited and drying will be faster.
So you are recommending little thicker paint. So
it is better. It gives you both power cost reduction and surface finish is much.
So B per cup value should be a little bit more.
Yeah.
Okay. Next question is related to, if sometime our sand comes in particularly in the rainy season in a moist condition, and it is very difficult to dry it. So people go with normally it is expected that 0.1 should be the moisture of the silica sand to be used for the core, but 0.2, 0.3 also somebody using, and they are not using any paint. So in that case, whether unpainted core can be passed through this oven to reduce the moisture content that core has having?
Absolutely. You can pass it through this to reduce the moisture.
So that moisture will be totally removed.
It will be reduced. Yes. In fact, there was one foundry from Kolhapur who was not interested in paint drying, but they were interested in reducing the moisture in the core itself.
Okay, great.
And
so they are using for this purpose.
Yeah. So in the same oven, they passed the CO2 based cores, where your silicate that was used, that had moisture, and that moisture was creating a problem. So we did some trials in the oven, and it can reduce the moisture in that oven also. There was no paint involved, just the moisture in the core.
So core become hotter in the nature?
Yes. They do become hot, but they don't become very hot like conventional oven.
What is the surface temperature approximately?
Typically, it would be again surface temperature. If you see, it would be around 95, 100, between that range.
Okay. So it is one of the we can say test for checking whether our cores are dried properly or not by using infrared gun
Yes,
You
yes.
can yes, you can
Yeah.
use.
Yeah, we can use that.
My last question is there any change in the color when we passes the core through oven after
Is
drying?
there any change in what?
Color, color of the core.
No. So that is again one of the advantages you can say. It will become slightly darker for sure because you're heating it to a certain temperature. But because microwave heating does not burn and it is attacking only the moisture and not the sand heating, so your color does not majority change. It remains almost the same.
And there will not be any peel off or the rubbing.
No,
Nothing will be there.
nothing.
The sand will not get looser.
Only thing is you may see a change in the color of the paint because when you apply the paint and it is wet, it will be looking more darker. After it is dried, it will become more brighter.
Core will not become pliable.
No.
Okay, great. Okay, sir. Thank you. I think I have covered almost all the questions which are in the mind of Foundryman regarding the core oven and the drying of the core and all these things. So thank you once again for your nice presentation and great information and knowledge given to the Foundry people
My pleasure.
on this. Last one question, which is not related to this core. Can we use this oven for heating raw material, that is the scrap?
What scrap?
Our furnace scrap like pig iron, MS scrap, or our risers, because we all know
No. As I told you,
yeah,
most of these materials, the metallic materials, it is not possible. We cannot heat them or preheat them. But yes, other raw materials which are oxides or which are minerals, they can be heated.
because only surface cannot be heated. It will go inside and moisture
Yeah,
should
and metals, if you heat scrap metal, whether pig iron or MS scrap or CRCA or any of these, or even the casting RR, then they will reflect the microwave. They will not heat the microwave.
Okay.
They are reflectors. All of them are micro reflectors.
Yeah, just a curious question, so
Yeah.
I thought I will ask that in the end as well. Okay, sir. Thank you very much for your nice presentation.
Thank you so much.
We'll be very grateful to you for this your time and your presentation.
My pleasure.
Thank you.
My pleasure. Thank you.
Thank you, sir. Thank you. Good night.
Good night.
Good night.